Have you ever looked at a massive structure like a bridge or an airplane and just trusted it? We all do. But what keeps those things safe are the people who can find flaws that are literally invisible. We're talking about cracks so small, so microscopic, that you could never spot them with your own eyes. Today, we're going to show you one of the coolest tricks they use to see the unseen.
So let's just start with that big question, right? How in the world do you find a crack that you can't even see? This isn't just a fun little puzzle. It's a huge deal in engineering and safety. I mean, a tiny flaw in the wrong place could lead to a total disaster. So finding these things? Yep, it's absolutely critical.
Well, the answer is in this amazing field called non-destructive testing, or just NDT for short. The name kinda says it all. It's about giving a part a full top-to-bottom health checkup without having to break it or cut it open. You can think of it like a doctor giving an MRI to a machine part. You get to see everything that's going on inside or on the surface without causing any damage. Okay, so here's what we've got on tap for this explainer. First, we'll talk about the specific method for finding these invisible flaws. Then we'll get into the simple science that makes it all possible. After that, we'll walk through the process, step by step, look at the different tools you'd use, and finally wrap up with where this technique really shines and where it doesn't.
All right, let's dive right into our first section. We're going to be focusing on one of the oldest, but still one of the most widely used NDT methods out there, dye penetrant testing.
So what is it? Simply put, dye penetrant testing, or DPT, is a way to find flaws that are open to the surface. And that is the key phrase right there, surface breaking. This method is a specialist. It's absolutely brilliant for finding tiny cracks or holes that actually break the surface of a material. But it can't see a flaw that's buried deep inside a part.
Now here's the best part. The way this works is so elegant and simple. It's not some super high-tech computer thing. It's just pure basic physics. The whole magic trick comes down to one principle, capillary action.
So what is capillary action? Well, it's basically the tendency for a liquid to pull itself into super tight spaces. It's the force that makes a liquid want to climb into a tiny crack all by itself, without anyone pushing it, and sometimes even working against gravity.
And you've totally seen this before. Just picture a paper towel soaking up a spill on the counter. The second the towel touches the water, the liquid just zips right up into the fibers, right? It looks like it's defying gravity. Well, dye penetrant testing just hijacks that exact same natural force to pull a really bright dye into cracks you can't even see.
So now that we get the why behind it, let's get our hands dirty with the how. We're going to walk through the entire process, A to Z, for how you'd actually do one of these inspections.
The whole thing really boils down to these 6 steps. First, and this is so important, you have to pre-clean the part until it's spotless. Then you apply your dye. You let that sit for what's called dwell time. After that, you carefully clean all the extra dye off the surface. Then you put on something called a developer, and finally, you look for the results. Let's talk about step 3 for a second, dwell time. This is the patient step. You've got to give that capillary action time to do its thing and pull the dye into even the smallest little imperfections. Depending on the situation, this could take just 5 minutes, or it could take as long as half an hour.
And then there's development time. So after you've applied the developer, its job is to do the complete opposite of what the penetrant did. It acts like a piece of blotting paper, pulling any dye that got trapped in a crack back out onto the surface for you to see. This also takes a little bit of time, but this is the step that really makes the magic happen.
You know, a test is only as good as the tools you use, and choosing the right kind of penetrant and developer can make a huge difference in what you find. So let's look at the different options you've got. Okay, so there are 2 main families of penetrants. First, you've got your visible penetrant. This is usually a really bright, vibrant red dye. When it bleeds out onto that white developer, you can't miss it, even in regular daylight. Then you have fluorescent penetrant. This stuff glows like crazy, a bright yellow-green. But you can only see it under a UV blacklight. It's like a secret message, and that glow makes it way easier to spot super tiny flaws, so it's usually the more sensitive option.
And even with the fluorescent stuff, it's not one size fits all. They actually come in different sensitivity levels, from ultra low all the way up to ultra high. So if you were inspecting a really critical part where even a microscopic crack is a huge problem, you'd probably reach for a level 3 or a level 4.
Developers come in a few flavors too. You can have a fine dry powder that you just dust on. You can have wet developers that are mixed with water. But honestly, the one you see most often out in the field is the non-aqueous type. It just comes in a regular aerosol spray can, which makes it super easy and portable to use just about anywhere.
So, we know how it works and we know what tools to use. Let's wrap things up by looking at the practical stuff. Where is this technique a superstar? And just as important, where does it just not work?
The pros for DPT are pretty huge. It's incredibly versatile. You can use it on metals, plastics, ceramics, pretty much anything that isn't porous. It's cheap, you can take the kits anywhere, and it gives you a real, actual picture of the flaw right on the part. It's the go-to method for finding all sorts of surface cracks.
But you have to know its limits. And the biggest one, we've said it before, but it's worth saying again, it only finds flaws that are open to the surface. It's useless on something porous like wood. And the whole test lives or dies by that pre-cleaning step. If that surface isn't perfectly clean, forget it. You're not going to get a good result.
And for that super sensitive fluorescent method, you've got to be precise. The rules actually say that the UV blacklight you're using has to hit the surface with an intensity of at least 1,000 microwatts per centimeter squared. There's a specific number for it, because you have to guarantee that even the faintest little glow from the tiniest flaw will be bright enough for the inspector to spot.
So after all the steps and the science and the different tools, what's the bottom line? It's really this. Dye penetrant testing takes a hidden danger, something you can never ever see, and it makes it completely, obviously visible so that somebody can fix it. It's just a really powerful, elegant way to help keep our world safe and running. And it kind of makes you wonder, doesn't it? What other tiny, invisible flaws might be hiding in plain sight in the world all around us?
And we want to mention that this explainer was put together based on source material prepared by M. Asif Iqbal from CI Mech Engineering Private Limited.